So we have seen that solid expands. Now we are moving on to liquid expanding. So basically we are taking a liquid and heating it up. So let me do it systematically. So as of now, the temperature over here of the liquid, let me take that itself. So it is T degrees Celsius. So we will start heating it. Okay, with a burner and stuff. And we'll get to see that the temperature of the liquid increases to T plus delta T. So what happens? What do you think will happen? So majority of the liquid will expand, right? For there are certain cases, there's few anomaly that we will discuss, but point is it will expand. So it has moved from say here till there, some few centimeter up. So the volume, original volume, say it was, I'm taking some random value, 45 centimeter cube. Okay, guys, again, some random value. I'm not even thinking of it. Okay, not 145, let's say 845. Yeah, that sounds okay. And here, because of the heating, say it has, with this reading and all that, you're getting to see that it has increased to 853 centimeter cube. So I have a quick question for you guys. So the question is, how much has the liquid expanded? Yeah, please answer this. How much has the liquid expanded? So you'll go with 45 and this is 5 and 8 centimeter cube. Is this right? Actually, no. Why no though? 45 and 53, difference is 8. But I'm telling it's not the actual value, actual expansion. Why is that? This is, I'll call this as apparent. Apparent means it appears to be so. It is apparent expansion. Why is that I'm calling it as apparent expansion? Why not the real expansion? Right? So, well, I'll give you guys a clue. See, any liquid, if you want to heat it, it has to be in a, yes, container, is it not? Any liquid, it has to be in a container, only then you can heat it. That being the case, what is that we're looking at? That being the case, when you start heating it, what happens? Even the flask in this case also expands. The flask also expands. So if it was, say, 845, it's a bit more actually. Let's consider it as 850, or say we have reached the brim per se, almost. And, or let me not do this. It's kind of, say it is V centimeter cube. And now the flask has increased to V plus 3 centimeter cube. Okay. So ignoring that it is not, the container is not filled with this liquid in completely, ignoring that part. So till the marked part, consider that the volume has increased from V to V plus 3 centimeter cube. Now can you tell me the actual value? Yes, we need to add plus 3. Why is that? Because even this plus 3 will be occupied by the liquid addition to this 8. It has to, na? Because the volume of the container is increased, right? So this is the volume of container increased. And we know that liquid takes the shape and occupies the space that the volume that it is put in. So that being the case, it should occupy this space also. So that's why it's called as apparent. It looks like that, but originally it is this. This is the answer. 11 centimeter cube is the actual expansion. Okay guys, and this is how you talk about liquid expansion. liquid expansion cannot be discussed without the understanding or measuring the container's expansion as well. And so let's move on to the theoretical discussion. Everything now there is a bit of math and bit theory. That's it. So let's read through what actually happens when a liquid is heated in a container. When you heat a liquid kept inside a container, so usually we keep it in glass, the liquid expands, right? The container also expands. Both expansion happens simultaneously. What do we actually observe? We see that the liquid level rises inside the container. This visible rise looks like the liquid's expansion, but it is not the complete expansion. But why is that? Why is the observed rise not the true expansion? Because one is the container also has expanded. Some part of the liquid own expansion goes into filling this expansion. Therefore, the liquid rise less than it would have if the container had not expanded. If the container had not expanded, if it had stayed V to V, then this 8 would have been right. But the container also expands. That's the truth. We can't run away from that. And so we have apparent and real expansion, two different things. Apparent is what we get to see, real is what actually happens. So the expansion that appears to have appeared to happen, that is the observed rise of the liquid inside the expanding container. The actual change in the volume the liquid would undergo if the container did not expand at all. Right? This is real and this is apparent. So gamma apparent, gamma real. Expansion of the container also will be given. It is also given a name, and that is your gamma G. So here the symbol represents coefficient, right? Remember coefficient of linear expansion, volumetric expansion. Here too we are dealing with coefficient of real cube expansion, coefficient of apparent cubical expansion, coefficient of cubical expansion of the container. So the idea continues the same, just that we have different set of formulas. So let me write it off because it's not easy to read over there. So let me start off. There's a relation math. All in all, there's a math that we need to know over here. So first I'll start off with coefficient of real, I think first one is cubical expansion. It doesn't matter. So we are talking about gamma real is equal to real increase in volume, this entire thing divided by original volume, right, into change in temperature. Okay. So similarly we have coefficient of, we'll write next apparent, cubical expansion. Again guys, these are all just names, the idea is the same. I write it as APP, apparent, short form. So here it's the same, apparent increase in volume divided by the same thing, original volume times delta T. Okay. Coefficient of cubical expansion of the container. This is the third thing that we need to consider. And it's generally G, glass and stuff. So we have increase in container volume divided with original container volume times the change in temperature. Okay. So there's one final relationship. And we actually kind of mathematically wrote that, in over here. So that would be gamma real is equal to gamma apparent plus gamma glass. That's it. So that is your math over there. Okay. And yeah. So in simple words, liquid expands, container also expands. Container expansion hides part of the liquid expansion. What you see is apparent expansion. What actually happens is real expansion. And mathematically, it's given by this. So it's a good summary. Okay, you guys can, my advice is, yeah, you can just take this with that heading and then write the math. So, okay, if you guys want to read and finalize it, I'll leave it to you guys. Go slide by slide.